Let's take a look at some different items. Our first one is scatter diagrams and linear correlation coefficient, though it doesn't say that. So we're going to do a scatter diagram and find R. Okay, let me come over here. And I'm going to have some X values and Y values. And let's take a look at some problems here. Well, get there eventually. And number 13 says make a scatter diagram for these data points right here. So let's take a look at that problem. So we got 3, 6, 12, 18, 24, then 60, 95, 140, 170, 185. Now for our scatter plot, scatter diagram, what we do is you highlight both the X's and Y's. You go to Insert, go to Scatter, and then you choose the first one here, Scatter Plot. And that gives you your scatter plot. Now you see that's the points right there. And then it says, draw the line you think best fits the data. Well, different ways you could do that. Very easy way, I think, is Insert, Line, make sure I'm in the right place. I'm not in the right place. Shapes. Shapes, and here's a line here. And then draw the line you think best goes through that data. And there you go. So that's a very easiest way, just to draw a line on your graph. Now you put it a different place, but this would be subjective. This is the best line you think goes through that data with the least amount of error. Maybe like that. Let me scroll down a little bit. It's asking us to find R here. To find R, you do an equals, correlation, see, and they have to have equals, and this has to be exactly like you see in it, C-O-R-R-E-L, beginning parentheses, and then we're going to put the X values or Y values, doesn't matter which one goes first. I'll do A2 to A6, so that's where I got my X values, comma, B2 to B6, so that's where I have my Y values, and then press enter. So then let's compare that against this. You see we got R is approximately 0.972. And it says a few more decimal places, but that's how you find R. So this is scatter plot, scatter diagram, and this is R. Okay, let me make this a little bit bigger so I can see it. There we go. And go back to section 9.2, linear regression and the coefficient determination. Go to 9.2 problems. Now some of these are based upon you finding the values given that they've already done some of the calculation for you. And that's pretty much just plug it into the formula, so I'm not going to show those, but I'm really interested in the ones where they give you the raw data. Looks like number 7 has raw data. So we got that there. X, Y, and what are my X values? 16, 33, 50, 28, 50, 25, 236, 593. Okay. Now, first thing it says is draw a scatter diagram. Just show that again. We highlight these and choose my insert, and then the scatter, and then scatter diagram. So that'd be our scatter diagram. You can see it's given by my points here. It's got a line on there, but isn't asking us to draw the line on that first part, so I'm not sure why they did that. That says verify this given sums and find the value of the sample correlation coefficient. Well, sum of x and sum of y and all those are given up above, and if you want to verify those, you could add these together. Sum of x's, just summing those together. You do equals sum, beginning parentheses, and then A2 to A7. And that'd give you 202, which should match what they're giving you right here, 202. If you wanted sum of y's, you come here. You can type that formula, but there's also the auto sum up here. If I click the auto sum, it'll fill that in, and I can do a check mark, and adds those together. Now, if I wanted x squared, I could do an equals A2. That refers to that first cell there, and then caret 2. That's how you do a squared. So 16 squared is 256. Now I click in this cell, and now put my mouse in the lower right hand corner. It becomes a plus. I click and hold down my left mouse button and drag it down, and it fills the formulas down. And I got a y squared, and then want to fill it down all the way there. Those are the sum ones. So we got equals b2 caret 2. And then I'll again fill this down. And we had xy. That's equals x, which is a2, times y, which is b2. And press enter, and then fill it down. And now I can come down here and click the auto sum on all of these. Or I could even drag and fill it over like that. And I should be able to go through and verify these values up above. But that's not really what I'm interested in. The instructions here basically find R. So let's talk about that. Okay, I'm going to get rid of those because I'm not going to do it by hand. R equals, that's just a description. Now do an equals CORREL, just like we did before. Doesn't matter which one you put first. I put the X's first, so here I have to put I'll put the Y's. B2 to B7, comma, A2 to A7. And that gives us our R. Use a calculator. What kind of answer is that? Anyway, that is our answer. I'm not sure why in the world they're being vague on the answer there. Oh, R is equal to 0.86 up there. Okay, so they give R. We're just verifying all of those. I guess I should read directions. Now this next part, we want to find, it says X bar, Y bar, A, and B, then find equation of the least squares regression. Now the A is our intercept, and the B is our slope. So, if I do intercept, I'm going to do equals intercept. Now here it's very picky. If I do a beginning parentheses, it asks us for known y's. So here you have to put B2 to B7. You can't put the x values first. And then comma, and here's where you put the x values, which is A2 colon A7. Now our slope. We're going to do an equals slope. And again, we have to put our y's first. So we do B2 to B7, comma, A2 to A7. And yeah, just double check. Okay. Well, now, let's see. Find the equation of least squares regression. A and B. A is negative 7.48 and B is 0.161. Okay, so that's how we're going to find our regression equation line. So the regression equation is y is equal to, and they tell you this, where do they tell you this? A plus bx. So A plus bx so our answer would be y equals, and A is our intercept, so we got negative 0.748, and B is our slope, so we got 0.161. And again, you'd modify that to however many decimal places they're asking for. In this case, they're asking for 3. Now, to say graph the least squares regression line on your scatter diagram. And so let's see how to do that. Now, I'm going to delete these columns. They weren't part of what I was trying to do anyway. And here is where I'm going to put y hat. Now, y hat is our prediction, and that's what this is. I didn't label it that way, but this is really y hat equals, even though the book kind of doesn't indicate that. Y hat is your prediction. So up here, I'm going to do an equals negative 0.748 times x, which is A2, plus, negative 0.748 plus 0.161 times x, which is A2. So all I've done is I went through and I typed this y hat in like you see it, with an equals in front. But where the x was, I put in my x value over here, which is A2, and I press enter. And then I'll fill that down. And this gives us these values. Now if I come over here and I right click and I right click the data. Okay, right click those, or click these with my left mouse button, and then I'll right click on it and let's see, select data. Let me go to that. Then that's referring to this. I want to add a new series, so I'll click add here, and this is going to be my regression line. Now for these x values, these are going to be the same x values we had over here, so I can come over and click and highlight those like that, or I could even type in equals A2 colon A7. Now here I could type in equals C2 colon C7. That refers to y hat values I just put in here. And then click OK. Got an error. C2 to C7. Formula type contains an error. I don't see an error. Equals C2 colon C7. That's interesting. Well, let me just come over here and click and highlight these. I shouldn't have had to do that. I should be able to type it in direct. In case you're wondering, what did I do? Well, get rid of this, blank it out, then you come over here and you click with your left mouse button your first cell, click and hold down, and drag down, and it'll fill that in. Then OK. And you see now the red is there, that's a regression line. And then I could come up here to Series 1, and I could choose an edit, and these would be our actual y values. So actual y values. And click OK. And then OK again. So we put more data points on here. Now if I click the red with my left mouse button, and then right click on it and say change series chart type, I want to change it to a line. So come over here to a line, and then click OK. Let's try it again. Change series chart type. Thought I knew how to do that. Let's try this, see if it works. If it doesn't work, then we'll try something else. Okay. Well, forget that. I'll go to the old school. I'll go up here to my insert, and I choose shapes, and then the line here. And I'm going to draw a line through those points. Try to make it as close as I can. That would be our regression equation. That would be the y-hat here. The negative 0.748 plus 0.161. It's kind of interesting why that wouldn't work. Some of these I tried beforehand because I haven't tried them before. Some are brand new. I've done a lot of this in the TA3, TA4. So a lot of this is brand new for Excel. Okay, and if I were to look at there, see figure in part A. Okay, then that more or less looks like this. You know, you change your vertical and your horizontal scale, you can get it to look more like that. But that's our graph. Okay, now I guess that's it for those. Okay, find the value of the coefficient determination. You see it says r squared is equal to 0.740. R squared equals 740. Take it 3 decimal places. What it is you just simply squaring your r. Now it should be an uppercase R here. Oh, that's interesting. Some books will put this as an uppercase R, but this is lowercase r. But again, all you're doing is just squaring this value. So all I did is equals b9 caret 2. And that gives us r squared. Okay, now some of these you can get, some of these values here, you can get with the data analysis. If I come over to data, choose data analysis, then you see there's a regression option here. If I choose that, input Y range, I'll come over here, click and drag down. Input X range, come over here, click, drag down. You see the residuals, normal probability plots, residual plots, line fit plots, a lot of different things we haven't talked about. If I click OK. See, we got r squared there. And it gives us r somewhere, I think. No, I think that's under correlation now that I think about it. There's a correlation option right here that you can also choose. And if you went and did this, I believe that gives you R. Let's see, standard error. Down here, you see there's the intercept, negative point. There it is. Negative 0.748. And our other item was a slope, 0.161. And you see that's down here. Now it's not labeled that way, it just says x variable 1. But that is your slope right there. And this is your intercept. Okay. Let me go back to the chapter contents. Now here we're talking about some different items you can do with correlation. And I'm not going to cover all these topics. I'll cover, if you're given raw data, how to handle it. Actually, let me talk about prediction before I move on to that. Let's say you're given a problem where they want you to predict y when x is equal to 42. And you're given raw data like this. Well, you find y hat here, which is this right here, And after you find y hat, then your prediction value, what you do is you do negative 0.748 plus 0.161 times 42. So whatever value you're trying to evaluate for, you're going to plug that in, and that's going to give you your prediction. This would tell us that our y value would be 6.014 when x is equal to 42, using this model right here. Regression is a model. Gives you something you can plug in x values and then predict the y values. Okay. Now this next part talks about some different confidence intervals and so forth you can create. And I've created a spreadsheet on this to try to help out. And this is where you're given certain x values. Let me see if I can find an example of this. It refers to Minitab, but since we don't have Minitab, I've had to create these spreadsheets myself. Some of these already got the values created. Okay, so this is where in the yellow, so you got 67, 65, 75, 86, 73, 73, and I'll delete that. 44, 42, 48, 51, 44, 51. There we go. And may not have my formulas here perfectly. Let me correct those real quick. Spent quite a bit of time working on these, but it's harder than I thought it would be. But it doesn't look like I have them quite perfect yet. Just putting if statements in there to make it a little bit easier to see. There we go. Now some of these may ask you different items. Verify these values here. You see the standard error is 2.69. A I don't actually list here. B and so forth. But A and B you can get using the regression equation. That's off the regression equation we looked at before. A lot of these don't ask you the exact values. Let's see. Now here, it says find a 90% confidence interval for y when x is equal to 70. So given this data, we want to find this confidence interval. What I came down, in yellow is where you actually input your data. Don't try to change any of these other numbers. You see I put 70 here, and then I put 90% over here. And our lower bound is 39.05, and our upper bound is 51.67. So that's how you find the confidence interval. Then again, these are, I haven't done everything here. I tried to focus on the specific ones that I thought that would be beneficial in Excel. But that's how you do a confidence interval for a prediction. I'm not going to cover what does that mean exactly. You'll read the book and read the interpretation and so forth. I'm just coming up with a spreadsheet to help you find it. Okay, so let me close that. And that was it for chapter 9, I believe. Now for chapter 10. Goodness of fit. Oops, sorry. 10.1, Test of Independence. I create a spreadsheet for this. Test of Independence is right here. And also got a PowerPoint. Talk about a little bit. Test for independence. These tests determine if one variable is dependent upon another variable. Example out of the book. Is a variable a number of hours studying dependent upon another variable like the major? We're going to use a p-value approach. Although we're going to use it in Excel. There we go. Come up with a null and alternate hypothesis. H0 states that the row and column variables are independent, while H1 states are not independent. So you just substitute in whatever your row and column variables are. If it's grades and major, you say H0 is that the grades and major are independent. And H1 always states they are not independent. And we're going to input our matrix in. Let me put into the spreadsheet. Yellow. So for example, this one over here. I got an example of testing a claim at alpha is equal to 5% for the connection between favorite color and number of children. Well, we're going to come over here and we're going to put our numbers in. So we got 20, 10, 5, 3, 10, 5, 3, 2, 1, 0, 30, 45, 51, 23, 12, 2, 7, 8, 12, 3, 8, 12, 3, 4, 5, 7, 2, 4, 5, 7, 2. And this would give us our p-value down here. Now, the only thing you ever want to change here is this yellow. It automatically calculates the number of rows and columns and gives you your p-value. Now, this said we're going to compare that against alpha is equal to 0.05. Well, this is scientific notation. This means 1.3 times 10 to the negative 6 power. That means we move our decimal point 6 places to the left. So we got 0.000013. Now that is less than alpha, so this says we reject H0. And if we reject H0, that means we accept H1. So we're rejecting that they're independent. Okay, now let me look at one in the book. 10.1. And here we got these values here. Now they already give us the row totals and column totals. They're trying to make it easier on you. But I got the spreadsheets already designed. You don't want to leave zeros in here for blank. You want it to actually be blank. So if I come over here, I want to press delete to clean these out. Okay, 62, 45, 68. 68, 94, 56, and 81. It says, what is the level of significance? Well, that's alpha. Alpha is 0.05. Now notice here, H0 is always the same. It says preference, personality preference, cross top, and occupation, profession, on the side here are independent. So you just always have these two say either are independent. And this says they're not independent. Now to find the value of the chi-square, Notice I got 8.649. Degree of freedom of 2. I don't have that listed, but that's the number of you do n minus 1 of each the row and column, multiply them together. And let's see, based on your find or estimate the p-value. Now p-value is 0.0132, which is what we got right here. Okay, will you reject or fail to reject the null hypothesis? Now alpha was 5%, and this is 0.0132. That's 1.32%. So p-value is less than alpha. P-value is less than alpha. That says we reject H0. So reject H0. And then you have to see whether your claim matched H0 or H1. You interpret it appropriately. Your answers on these may not match the spreadsheet exactly because this is rounding to the hundredths place you see here. And in my spreadsheet, I'm not rounding at all. The E is your expected frequency down here. Now, there are restrictions on what E has to be in order to use this test. So that first example I gave you was not valid based upon the E's. But anyway, that's how you do a test of independence. So let me close that. And next thing we'll take a look at is a goodness of fit test. Now, hypothesis for goodness of fit test, a null hypothesis always specifies probability for each category. The alternate hypothesis says that some or all these probabilities differ from the true probabilities of the category. The idea here would be, for example, we expect 20% A's, 30% B's, 20% C's, and so forth. So you're given a probability or a percentage for each individual category. P-value approach. Write down a shortened version of the claim. Come up with a null and alternate hypothesis. See if your claim matches H0 or H1. Put your observed into column A. I should have had this changed. I apologize. I didn't realize that I didn't have it. Expected in or P into column B. And then we'll find our p-value. Okay, we'll come back to that. Let's come over here. We've got our claim following our observed frequencies. The null hypothesis is H0. P1 is equal to 0.25, P2 is equal to 0.20, P3 is equal to 0.50, and P4 is equal to 0.05. So I come over here. Your observed is your actual values down here. So 200, 150, 350, 20. And our p-values, 0.25, 0.20, 0.50, 0.05, and then I'll get rid of that. Okay, so you put in your observed here. That comes from the table. And then your p-values, which comes from your H0. Those go right here. And this gives you your p-value. You notice your p-value is 0.0198. And assuming 5%, this doesn't say, but if it doesn't say you assume 5%, then the p-value is less. So down here, p-value is less than alpha. That says we reject H0. Well, let's compare this to a problem in the book. And chi-square goodness of fit. And we got this. Let's take a look at this one. Observed number in Red Lake Village. So this is a Indian community of Red Lake Village. So we got 47. 75, 288, 45, 7.2%. That'd be 0.072. 0.136 for 13.6%, 0.671 for 67.1%, 0.121 for 12.1%. What is the level of significance? Is 5%. Notice that H0 is the distributions are the same, H1 distributions are different. This is what it always says. Chi-square statistic. Do I have that? Yeah, I did put it. 11.789. A little bit difference for rounding there if I did it. Degree of freedom is 3. That's 1 less than the 4 here. Find or estimate the p-value. So he gives a range here. Ours is a little bit more precise. Not saying I'm better or anything like that, but we're not looks up in tables. We're using this spreadsheet here. And you see I got 0.008, which is definitely between these two values. Now our p-value is 0.008, and alpha is 5%, so p-value is less than alpha. So if p-value is less than alpha, reject H0. So when it asked, what are you going to do? We're going to reject H0. And then that's how you'd answer that type of problem. Now, I've created these spreadsheets. I think they're pretty robust, which probably means I got a lot of errors in them. No, I've done a lot of checking on it over the last 3 days, so I think these are in pretty good shape. But if you do find where they're not giving you the correct answer, please let me know so I can correct them and get the correct spreadsheets to everybody. After one class of this, I'm assuming that I'll probably have these pretty well designed and there won't be any of those errors.